In this next and final chapter, we can discuss a little bit about the norms and regulations that are now used within the industry and shape the market. So what are we trying to achieve? So the product must provide liability, and we can compare this to the building of a house, where liability is the roof that provides shelter. The walls that support the roof are safety, security, and compliance with the regulations, and you can see that there are plenty of norms and regulations for this. And finally, the development process forms a solid foundation to provide quality standards to everything above. As important or even more important than the types of key management and cryptography methods used for the products, we need to focus on the entire process, from a threat analysis and risk assessment to the security requirements and implementation and testing. It is estimated that roughly 60% of project failures are due to lack of requirement engineering process or methodology, and 80% of cyber attacks happen due to lack of focus on security requirements during the project implementation. For this presentation, I'm not going to dwell deep into all of the standards that exist, because I don't really know them all. But we should take a brief look at the most relevant in the cybersecurity development process. So we are talking about the ISO 21434 and Security A-Spice. The ISO 21434 provides guidelines for implementing security by design in the automotive industry, such as item definition, which is the starting point of the security design, where the development teams provide a holistic view of the system to be protected. Threat analysis and risk assessment, or TARA, is the process of identifying all the potential threats to our product and analyzing its risks. In this process, it is calculated the impacts of such threats and the probabilities for them to occur. After this complex analysis is done, the manufacturer can decide how to address the risks and define the security goals for the product. This process takes the inputs of another process called vulnerability analysis. Here, all known vulnerabilities of the assets are compiled to add with the threat analysis by showing how an attack can take place. The end result of the security concept, which is a set of requirements derived from the security goals that are later handled to the implementation teams. And now for A-Spice. This is a methodology widely used in the automotive industry that includes the well-known V model. Each discipline can have its own V, like mechanical engineering, hardware engineering, and software engineering. This is especially useful to give a visual aid on how the several processes involved in manufacturing are connected and dependent on each other. From the top to bottom, we have the several stages of development, from the high-level requirements to the software implementations. And from left to right, we have the development side of the V and the validation side of the V. The Security A-Spice is a version of A-Spice that couples security's ISO 21434 with the previously established process that encompassed the safety's ISO 26262. And finally, the regulations that arrive to the market. So, the United Nations Economic Commission for Europe, or UNESI, has been long working on cybersecurity regulations and finally published its first regulations for the automotive industry in March 2021. The UNESI R155 and 156 provides an extensive set of requirements that are non-negotiable and can be fulfilled by following the previously mentioned standards. These requirements are extremely important as of today, since the European Union passed the law making these regulations mandatory since July 2022. Thanks to this, other markets are following the same trends, such as Japan and South Korea, that are also major exporters to the European market. And that was all. We reached the end of our series. Hope you liked it, and thank you very much.